Hello everyone. In this lecture, let us have a look at image gradients using Sobel filter. So in programming, our first step would be to import our libraries. So let's import our CV2 library. Along with it, let's also import NumPy library as NP, and we also need to import our data visualization library. So let's import from matplotlib. Let's import our pyplot as PLT. Along with this, in order to make sure the backend and the front end of the plot is in line, let us also give a line percentage or modulus matplotlib space inline. So let's run this to make sure our libraries are imported as required. After this, we have to read in our image. So let's create a variable called img, and let's assign this the cv2.imread function, and inside this I will be calling black and white.jpg, and I will make sure I am setting the flag as 0 over here. So once I have read in the image, my next step is to apply the Sobel filter. But before we apply that, an important information we have to keep in mind is that this filter is resistant to the different noises present in an image. So let's go ahead and create a variable called img_sob and assign the cv2.sobel function to this. This function takes in 5 arguments. The first argument is going to be our source image. The second argument is the depth. This is the depth of our output. So let us set the depth to cv2.cv_64f. So I finished 2 arguments. The next two, that's a third and the fourth argument, will help us determine in which direction the gradient is going to be applied in. So these two arguments are dx and dy. So let's set the dx as 1 and dy as 0, indicating that I want the gradient to be applied in the x-axis and not in the y-axis right now. Last but not the least, the fifth argument is the extended Sobel kernel size. So the case size is going to be set as 5 for the time being. So let's run this to make sure there is no error. So at this point, you guys could be asking me, why are we keeping k size as 5, x direction as 1, y direction as 0? At this point, this is the values which I am going to be setting so that we get to see the output. Afterwards, I would request that you guys go ahead, try changing the k size first. Then try changing, instead of applying the kernel in the x direction, let us apply it in the y direction. And then try the combination of both to see the output. So now we are going to write the code for displaying the image for us. So we will be using the PLT or the matplotlib library for displaying. So plt.subplot, inside this let's give 1, 2, 1. As you all know, 1, 2 indicates the row and columns which are required, and the last value 1 represents the position. So this is followed by plt.imshow. I want to display the original image. So I'm going to say img, cmap is equal to gray. After this, I'm going to say plt.title, and I'm going to give the name original image. Okay. After this, I have to make it in a manner where both my x-axis and the y-axis is not displayed. So I'm going to say plt.xticks, that is TICKS, inside brackets, let me just open and close my square brackets. So similarly, plt.yTix, open and close round brackets, open and close square brackets. So now I have written the code for displaying our original image. So now let us create the code for displaying our Sobel image. So the two lines will be the same. plt.subplot 1, 2, 2, because this has to be in the second position, comma plt.imshow. This will be img underscore sob, comma cmap is equal to gray. Then this is followed by a title. So plt.title, let's call it Sobel X image, comma plt.xtix, let's close it, along with plt.ytix, open and close square brackets. So now that I've finished giving the instructions for displaying my original image as well as my Sobel X image, next I have to say plt.show, only then will my images be displayed. So let's see how my image looks like. So as you guys can see, maybe in my screen right now it is not very clear for you people. So in your screen, try zooming it in order to see the output more clearly. You can see the intensity changes in the x-axis in the output image. So you guys can go ahead, like I mentioned, try changing from x-axis to y-axis, and also try changing the kernel size. Thank you. See you guys in the next lecture.